Welcome to 4Keys Private Tuition. To this one of my must-watch videos for all O-level chemistry students. The stuff that we're going to discuss here also work for A-level chemistry. So if you have an A-level SimSec or Cambridge student, you can also watch this content. This is very important. So we're going to be talking about molar gas volume, and we have a simple equation that relates here the number of moles and the volume of a gas, which says volume of a gas is equal to moles, the number of moles times your 24. In other cases, you may be given 28 cubic decimeters to represent the volume of a gas, the volume of 1 mole of a gas under room conditions. Okay, so let's go straight into what we have to discuss here. So this equation works for any gas whatsoever. It could be chlorine, it could be water, or any gas that you have. It will occupy a specific volume. 1 mole of a gas will occupy a specific volume under specific conditions. And if you're given 24 cubic centimeters, it's under room conditions, or in with the SimSec, you may be given 28 cubic decimeters as your molar gas volume. So let's look at an example. If you have 3.5 moles of chlorine gas, so what is the volume of 3.5 moles of chlorine gas? What you simply have to do is multiply the number of moles times your molar gas volume, and you get 84 cubic decimeters. Okay, the equation also works the other way around. If you're given your volume, you can be asked to find the number of moles. So how many moles are there in 60 cubic decimeters of oxygen under room conditions? So what you simply have to do is rearrange your equation such that you make number of moles the subject of the formula, making it moles is equal to molar gas volume divided by the volume of a gas given divided by your molar gas of volume. So if we do so in this example, we're going to have 60 divided by 24, which gives us our 2.5. Okay, in this case, we're given 27 grams of water, and the question is, what is the volume? So you can be given the mass, and if you are given mass, then what you simply have to do is convert your mass to number of moles. And we know that for you to find the number of moles, there's another equation that you have to use, which says that our number of moles is equal to mass of a sample divided by the MR. So you need to find the MR of water. So you're given the mass of the sample of water, which is 27 grams, but you need to find the MR of water. And water, the formula is H2O. So if you are to find the MR, then you have to multiply 16, which is the mass of oxygen, plus 2 times the mass of hydrogen, because we have 2 hydrogen atoms there, giving you 18 grams. So 18 grams is the MR. So we're going to say the mass of the sample of water that we're given, which is 27 grams, divided by 18, and we get 1.5 moles of water. So this is how we now are able to use the molar gas volume equation. So what we simply have to do now is to say our 1.5 moles times our 24, which is the molar gas volume, and we get 36 cubic decimeters. Okay, let's look at other examples. Find the volume of a product when you're given the volume of a reactant. So when we are doing this, what we have to do is we have to look at our balanced equation. So you can find the volume of a product that is formed given the volume of reactants that are used. So let's look at this specific example. What is the volume of ammonia that would be produced in that reaction? If we reacted 18 cubic decimeters of nitrogen, so we're given the volume of nitrogen that we are reacting, and we're asked to find the volume of the ammonia that we are going to produce. And we are given extra information here, which says that the nitrogen is reacted with excess hydrogen. So this means that our nitrogen is the limiting reagent here. If you remember, we talked about limiting reagents earlier on. If you haven't watched that video, please go and check that the video that we made on limiting reagents. Okay, so the limiting reagent is going to determine how much of the product we form. So we need to find how much of the limiting reagent is available in terms of number of moles. So what we simply have to do here is convert our volume to moles using our equation. So we're going to say the volume given divided by the molar gas volume, which is 24 in this case, and we get 0.75 moles. So 18 cubic decimeters of nitrogen is 0.75 moles. The next, we need to look at the molar ratio in the equation. So if you have 1 mole of nitrogen, according to the equation, you're going to form 2 moles of nitrogen gas. So with that molar ratio in mind, what you simply have to do is multiply the amount of nitrogen that we begin with, which is 0.75, times 2 in order for us to get the amount of ammonia that would be produced. This is according to the balanced equation, the molar ratio. So we're going to get 1.5 moles of ammonia. Now, once we have the number of moles of ammonia available that will form, remember the question is asking us the volume of ammonia that would be produced. So what we need to do is now use our molar gas volume. So 1.5 moles times 24 cubic decimeters, you're going to get 36 cubic decimeters. So it's important for us to know that you can work with volumes just the way they are. You don't have to change your volumes to moles. You can just work with volumes. If this reaction is happening under the same conditions, so our reactants are in the same conditions, the products are in the same conditions. So in that case, we can simply work with our volumes. We are given volume of the nitrogen and we are asked to calculate the volume of the ammonia that is produced. So we are just working with volumes here. So in that case, you can simply multiply the volume. You can simply use your molar ratios directly on the volumes. So the molar ratio says 1 mole of nitrogen requires 2 moles. It's going to produce 2 moles of ammonia. So if you're given 18 cubic decimeters, you're going to produce 36 cubic decimeters of ammonia. That is to say, the volume of nitrogen by 2. So you can work with volumes given that this is happening under same conditions. Let's look at another example here. If you start off with 4 cubic decimeters of nitrogen, how much ammonia are you going to produce? But actually the question is how much hydrogen would it react with? So if you have 4 cubic decimeters of nitrogen, how much hydrogen do you require? So if we look at the molar ratios there, we have a 1 and a 3. So molar ratio is 1:3. So 4 cubic decimeters are going to require 3 times that amount for the hydrogen. So 4 times 3 we get the amount of hydrogen that is required to react with our 4 cubic decimeters. So this works because we have our gases under the same conditions of temperature and pressure. If that changes, if that condition changes, then this no longer works. So it works once we have all the reagents or the products under the same conditions of temperature and pressure. So this is important for you to remember. Meet you in the next video.